Welcome to Lesson 6. In Lesson 6, we're going to talk about subtracting fractions. Just as I mentioned in Lesson 5, adding fractions, all we need to do is combine what we know about fractions and what we know about subtraction, and subtraction of fractions becomes relatively easy to do. What do we know about fractions? We know that the denominator is the place value. What do we know about subtracting? Well, subtracting is the opposite of addition. It involves counting, so we must have the same place value. So in order to subtract fractions, they must each have the same denominator. So we're not going to even look at any problems that involve fractions with the same denominator. We'll go right to a problem that's subtracting two mixed numbers with different denominators. And that first problem, of course, is 8 5/8 minus 2 1/3. And you'll notice that we've already set it up. We have the common denominator of 24. 3 times 8 is 24. Notice I've written the whole numbers, 8 and 2, and I've put that subtraction symbol in to remind me that I'm subtracting, because otherwise I might be tempted to add. Well, 15 24ths is equivalent to 5/8. 8 24ths is equivalent to 1/3. I subtract 15 minus 8 and get 7 24ths. 8 minus 2 is 6. There's no simplifying when it comes to subtraction, because obviously we're not going to get an improper fraction. If we get an improper fraction, it means we've done something improper. This is equivalent to the fact that there's no carrying in subtracting whole numbers. Simplifying is a lot like carrying. It's the same idea. So we are not finished, because we need to check to see if we can reduce. Can we reduce 7 24ths? Well, 7 is not divisible by 2 or by 3 or by 5. It is divisible by 7, but 24 is not divisible by 7, so we cannot reduce this fraction. The answer is 6 7 24ths. Now that wasn't so difficult. Here's another problem. 7 5/6 minus 3 3/4. Notice again, we've got it set up. We write the whole numbers, we put the subtraction symbol, the minus sign, and we have our common denominator of 24. 4 times 6 is 24. The numerator is 20 in the first fraction, because 5 times 4 is 20. In the second fraction, the numerator is, let's see, what is the numerator? It's 18. 18 because 3 times 6 is 18. So now I subtract. 20 minus 18 is 2, so 2 24ths. And 7 minus 3 is 4. 4 2 24ths. Well, that can be reduced. The 2 24ths, both of those are even numbers. I divide top and bottom by 2, and I get 4 1/12, which is the final answer. In the next visual, we'll see an alternate way to do this. That is, using the lowest common denominator. Just as I mentioned in Lesson 5, if you don't want to use the lowest common denominator, if you want to always get the common denominator by multiplying the two denominators, that's fine. But sometimes using the lowest common denominator will make the problem a lot easier. In this case, we use 12, because both 4 and 6 divide 12. We get 10 12ths minus 9 12ths, which is 1/12. And of course, 7 minus 3 is still 4. We get 4 1/12. And by using the lowest common denominator, we did not have to reduce. When you use the lowest common denominator, it does not guarantee that you'll not have to reduce. It just reduces the amount of times you'll have to reduce, because you're using a smaller denominator. Now, the next problem, 8 1/3 minus 3 3/5. When we get the common denominator, as shown here, 15, that's fine. We have 8 5/15 minus 3 9/15. That is a problem. Why is it a problem? It's a problem because we cannot subtract 5 minus 9. What did we do with whole numbers when we had a subtraction problem in a certain place value that couldn't be done? We had 2 minus 5 or 3 minus 8. What did we do? One word: we borrowed. And we'll do the same thing here, because as I said early on in Lesson 1, subtraction, addition, multiplication, etc. are consistent. What we do with fractions is really not much different than what we do with whole numbers. We will borrow. But some people, I should say many people, have a problem with borrowing with fractions, because it's not precisely the same as borrowing with whole numbers. In borrowing with whole numbers, a lot of people just are trained to put a little 1 up there. Well, you can't put a little 1 up here in the numerator. It's not correct in most cases. So what I've developed over the years is a story. And let's take this exact problem, this problem of 8 and 5/15 minus 3 and 9/15. Well, let's say, for example, that there was a new coin, a new U.S. coin. Let's call it the Molly. And a Molly is 15 Mollies make $1. Okay, so if you have 15 of these coins, you can trade it in for a dollar bill. And let's say I always keep my coins in my pocket. I keep my dollar bills in my wallet. In this particular case, I have 8 dollar bills in my wallet, and I have 5 Mollies, 5/15 of a dollar in my pocket, in my change pocket. I go to the store. I'm going to buy something. Let's say I'm buying some simple, some tennis balls. And the tennis balls come to $3 and 9 Mollies. Well, I don't have 9 Mollies. All I have is 5. So what do? Well, I go to give the person behind the counter $4. The person behind the counter says, "I'm sorry, I have no change. I'll just keep your $4. Well, I'm not used to giving tips to people when I purchase tennis balls. So I said, "Whoa, no, I've got to get my change. I'm not getting it ripped off here. What can I do? I want to buy the tennis balls. You don't have change." He said, "Well, if you go across the street, there's a store over there, and they always have lots of change, and they'll be happy to give you change for $1. Okay. So I put my dollars back in my wallet. Remember, I had $8 in my wallet. I had 5 coins, 5 Mollies in my pocket. I go across the street to the other store, and the lady standing behind the counter, I say, "The gentleman across the street said I could get change for $1. And she said, "Fine. What would you like?" Well, I told her I'd like Mollies. Well, if I give her $1, how many Mollies will she give me? She'll give me 15. Why? Because 15 Mollies, 15/15 of a dollar, equals $1. Now, am I going to take those 15 coins and hold in my hand as I cross back across the street? No. My mother trained me better than that. You don't go across the street holding money. You put it in your pocket. Now, wait a second. I already had 5 Mollies in my pocket. I put 15 more. How many Mollies do I have? I have 20. How about my wallet? Do I still have $8? Of course not, because I gave the lady $1, so now I have $7. Do I still have the same amount of money? I have $7 and 20 Mollies. Is that the same as $8 and 5 Mollies? And the answer is, of course it is. It's exactly the same. And now I can go to the store and give the gentleman there $3 and 9 Mollies. And what do I have left? Well, I had 20 Mollies. I have 11 left. I had $7. I gave him 3, so I have 4 left. If you can remember that story, then what we'll do next on the in the visual makes a whole lot of sense, because we'll do the exact same thing, only we do it symbolically. We have 8 and 5/15. We change the 8 to 7 plus 1. That is the $1. So we have 7 plus 1 plus 5/15. And then we change the 1 to 15/15. Notice, whenever you change 1 to a fraction, the numerator and denominator are the same. So if instead of 15s, we had 18s, it would be 18/18. If it was 24ths, it would be 24/24. We have 15/15. So we have 7 plus 15/15 plus 5/15, which gives us 7 and 20/15. Just as we said, I had $7 and I had 20 Mollies, 20/15 of a dollar in my change pocket. And now the next visual will show us symbolically how to subtract. We have 8 and 5/15 minus 3 and 5/15. I'm sorry, 3 and 9/15. And we borrowed. We actually borrow 1 from the 8, making it 7. And then we change the 1 whole into 15/15. An easier way to do that is to simply add the 15 in the denominator to the 5 in the numerator, giving us 20. Because, again, if we're changing 1 whole into 15ths, it will always be 15/15. So we have 7 and 20/15 minus 3 and 9/15. We now can subtract. We've borrowed, and we have enough in the numerator in the top fraction to subtract. 20 minus 9 is 11, 11/15, and 7 minus 3 is 4. So we now can borrow, and borrowing, you'll notice, is very much the same as with whole numbers. The only difference is that you don't just put a 1. You got to think about, if I have, for example, a common denominator of 30, then I'll simply change one whole into 30/30ths. But again, the easy way to do it is to simply take the denominator, add it to the old numerator, and you get the new numerator. Of course, this is only after you've gotten the common denominator. So let's look at the next problem. We have 9 2/3 minus 4 11/12. Common denominator, we use the lowest common denominator of 12. 9 8/12 minus 4 11/12. Well, can we do that? No, we can't. We cannot do, why not? Well, because we cannot subtract 8 minus 11. So what must we do? We must borrow. We borrow from the ones place, and the 9 becomes an 8. We change that one whole into 12/12. The 8/12 we had before, plus the 12/12 we added, gives us 20/12. And now we can subtract. 20/12 minus 11/12 is 9/12. 8 minus 4 is 4. We're not finished yet, because 9/12 can be reduced. By dividing top and bottom by 3, we get 4 3/4. So that's our final answer. That shouldn't have been so difficult. Again, the idea of common denominator, always going to have that to add or subtract. If we cannot subtract the top numerator minus the bottom numerator, we borrow from the ones place, and then we can subtract, we see if we can reduce, and we have our final answer. Now, there are two types of fraction subtraction problems that sometimes present a challenge. Actually, they're fairly simple problems, but they're a bit different. And in both cases, they involve where you have a subtraction problem with two numbers, only one of which has a fraction. For example, the first problem, 9 11/15 minus 4. Well, notice, the 4 has no fraction. If our first step in subtracting fractions is to get a common denominator, we might as well get one. We might as well use the 15. If 4 has no fraction with it, we can make it 15ths. But how many 15ths is it? Well, 4 and how many 15ths equals exactly 4? Seems quite obvious. 4 and 0/15 equals exactly 4. So our numerator for our new fraction is 0. That is 4 equals 4 and 0/15. Can we subtract? Can we do 11 minus 0? Of course we can. 11 minus 0 is 11. 9 minus 4 is 5. And our answer is 5 and 11/15. Do we have to reduce? Well, actually, because we only had one fraction, if 11/15 could not be reduced, and it cannot be reduced, then when we get our answer, we don't even have to worry about reducing. Okay? In other words, if the fraction in the top number, the one number with a fraction, cannot be reduced, then when we subtract, the answer will not have to be reduced. Of course, if we could have reduced 11/15, we could have reduced it at the beginning before we even started the subtraction process. Quite simple, but again, people look at it and they see the missing fraction and they get all hung up on what to do. Simply common denominator, the same denominator as the other fraction, and put a 0 in the numerator. Very much equivalent. Okay, the next problem. Now you'll notice the missing fraction, or the number without a fraction, is on top. We have 8 minus 5 and 2/7. Same idea. The common denominator is 7, right? Might as well use the same denominator, and the numerator is 0 because 8 and 0/7 is the same as 8. But now we can't subtract. We can't do 0/7 minus 2/7. So we borrow. No different. We borrow 1 from the 8, which makes it 7. We add the old denominator to the old numerator, 7 plus 0, to get the new numerator, 7/7. Is 7 and 7/7 the same as 8? Well, of course it is. And now we can subtract. 7/7 minus 2/7 is 5/7. And 7 minus 5 is 2. So the answer is 2 5/7. Can we reduce? No. And the same thing is true here. If we could not reduce the one fraction in that problem, after we subtract, we'll not have to reduce. Okay, so in these kind of problems, for example, if that had been 8 minus 5 and, let's say 2/8, we could reduce right there, make the 2/8 1/4, and still, after we subtracted, there'd be no reducing. So these are very special kinds of problems, but still it's a good idea to think about the steps. And in this case, some of the steps are quite simple. But always, when subtracting numbers with fractions, the first thing we need is a common denominator. Then we simply get the numerators in the equivalent fraction. We borrow if we need to. We subtract. And then we reduce our fractional answer if possible. And if we follow those steps, every time we'll get the right answer. Let's see if you can get the right answer. Let's go to the whiteboard and work a few problems. And again, as usual, what we'll do is I'll present the problem. You take a look at it, turn off the tape, and work the problem to the best of your ability. And then we'll see about how I would do it. Let's see. Let's go ahead and get a problem. Here's one. How about 9 5/8 minus 2 5/6? Okay. Using our steps, common denominator, numerators of equivalent fractions, borrow if necessary, subtract, reduce if you can. Using those steps, go ahead and work this problem, stop the tape, and come back when you've finished and have a final simplest form answer. Okay, as always, I'll start out by putting my whole numbers and my minus sign. What is the common denominator? Well, you could have used 48, but let's go ahead and use 24 since 8 and 6 both divide 24. We'll use the lowest common denominator. 8 times 3 is 24. And if you're still having some difficulties getting the equivalent numerators, especially with lowest common denominator, you might want to do this. Go ahead and put the multiplication numbers in. 5 times 3 is 15. 6 times 4 is 24. Therefore, we must multiply 5 times 4 and get 20. So now we have our second step taken care of. We've got the numerators of the equivalent fraction. Well, do we need to borrow? If the answer is no, we go on. If the answer is yes, we borrow. Do we need to borrow? The answer is yes. 15 minus 20 cannot be done. So, we borrow. We borrow 1 from the 9, which gives us 8. And then simply, rather than talking about 24 24ths plus 15 24ths, which would be correct, we simply add the 24 20 down here to the 15, and we get 39. That is, 8 and 39 24ths is the same as 9 and 15 24ths. And now we can subtract. 39 minus 20 is 19. 19 24ths. 8 minus 2 is 6. The last step is to see if we can reduce. Can we reduce 19 24ths? And the answer is no. 2 does not divide 19. 3 does not divide 19, since 1 plus 9 is 10, and 1 plus 0 from 10 is 1. We need 3, 6, or 9 in order for it to be a multiple of 3. 5 does not divide 19, since it does not end in 5 or 0. And in fact, the only thing that divides 19 other than 1 is 19, and 19 does not divide 24. So we cannot reduce this fraction. This is our final answer, 6 and 19 24ths. Again, it always looks simple when the instructor does it. But if you followed step by step and thought about what you're doing, this is not a very difficult thing either. And I know from past experience, especially working with adult students who believe from their school days that they could not do this, a problem like this would be crushing. They just give up when they saw it. In actuality, you could see it's not very difficult. They could do it, you could do it, anybody who took the time to learn the steps and work it carefully and with confidence would get the right answer. Okay, let's take another kind of problem. See if we do that. Let's see. How about 10 minus 6 and 15 23rds? Okay, I'd like you to work that problem, get your answer in simplest form, and then turn the tape back on when you've completed that computation. Okay, the first step is to get a common denominator. Well, we might as well use 23, since one fraction doesn't have a denominator. It could be the same denominator as the other fraction. The second step is to find the numerator of the equivalent fraction. 10 and 0 23rds is the same as 10. The third step is to borrow if necessary. Do I need to borrow? Can I subtract 0 minus 15? Not most days. No, you can't. I've got to borrow. So I subtract 1 from the 10. I borrow 1, leaving me 9 ones. And I add the 23 plus the 0 when I get 23 23rds. Is 9 and 23 23rds the same as 10? And the answer is, of course it is, which means we now have an equivalent number and we can subtract. 23 minus 15 is 8. 8 23rds. 9 minus 6 is 3. Can we reduce 3 and 8 23rds? Well, there's two ways to look at that. You can say I couldn't reduce 15 23rds, so I certainly can't reduce the answer. Or if you didn't remember that fact, we could say, is there a number that divides both 8 and 23? Well, 2 divides 8, but not 23. 3 and 5 do not divide either number. And that's it. There is no number other than 1 that divides 8 and 23. So the answer is 3 and 8 23rds. Okay, another problem for you. This problem is 10 and 1/6 minus 4 and 7/10. Okay, again, using the 5 steps, subtract, write your answer in simplest form, and turn the tape back on when you're done. First thing I'm going to do is write my whole numbers. 10, of course, I'm going to subtract 4, and I need to get my common denominator. Now, I could use 60, 6 times 10, but I'm going to use the lowest common denominator, and I know that 30 can be obtained by multiplying 6 times 5, and 30 can be obtained by multiplying 10 times 3. So my lowest common denominator is 30. 6 times 5 is 30. 1 times 5 is 5. 10 times 3 is 30. 7 times 3 is 21. Can I subtract? Not without borrowing, because 5 minus 21 cannot be done. So what shall I do? Borrow from the 10. I have 9. 30 plus 5 is 35. And again, you can double check that 9 and 35 thirtieths is the same as 10 and 5 thirtieths, which of course is the same as 10 and 1/6. Now I can subtract. 35 minus 21 is 14. 14 thirtieths. 9 minus 4 is 5. I was thinking ahead of myself and said the answer rather than what subtract. 9 minus 4 is 5. Can I reduce 14 30th? Yes, I can. They're both even numbers. Don't forget your whole number. It's very important. Dividing top and bottom by 2, I get 7/15. So 10 and 1/6 minus 4 and 7/10 is 5 and 7/15. Is that the answer you got? If it is not the answer you got, go back and work the problem again. But first, look at what you did that was wrong and correct it by doing the problem again in the proper fashion. Get the answer of 5 and 7/15. Okay? Let's try one more problem. Hopefully we're doing well here. And again, this is not that difficult. The key thing is step by step, not trying to do the entire problem in one shot, but doing each of the steps step by step. Let's see, how about 18 and 3/10 minus 11 and 1/2? Same idea. Go ahead and stop the tape, work the problem, get it in lowest terms, turn the tape back on, and we'll work the problem together. Okay, let's see. Write down my 18 minus 11, common denominator. Common denominator, of course, is 10. You could use 20. In fact, you could use 1,000, any number that's divisible by both by 2 and 10. But let's use the lowest common denominator, 10. 3/10 was equal to 3/10. That was tough. 1/2, well, 2 times 5 is 10, so 1 times 5 is 5. Can I subtract? Can I subtract 3/10 minus 5/10? No, I can't. So I'll borrow 1 from the 8, leaving me 7 in the ones place. Change that 1 into tenths. 10 plus 3 is 13. 13 minus 5 is 8. 8 tenths. 17 minus 11 is 6. So 6 and 8 tenths. Can I reduce that problem? Yes, I can. 8 and 10 are both even numbers. I divide by 2, writing down my 6 first. 8 divided by 2 is 4. 10 divided by 2 is 5. 6 and 4/5. Can I reduce 4/5? Nope. The only number that divides both 4 and 5 is 1, so 6 and 4/5 is the answer. 18 and 3/10 minus 11 and 1/2 is 6 and 4/5. Now, let's do one more. We have one more problem to be done. How about this one? 736 and 15 298ths. Now, what did I draw that line for? I don't know. I'm so excited about these big numbers. Minus 104. That looks like a very strange problem. There's a reason for my doing that. Go ahead and work the problem, come up with the answer, and return to the tape, and we'll work the problem together. Before I work the problem, what I was trying to get at here, these numbers are quite large. The denominator is quite large. But in this particular type of problem, that's irrelevant. It's a very simple problem. Because in reality, we need a common denominator. The common denominator is 298. Now, generally, you'd never see a problem with that large a denominator, but just for the fun of it, we did it. The numerator, of course, is 0. Can we subtract? Of course we can. There's no need to borrow. 15 minus 0 is 15. The denominator stays the same. 736, we're back to a subtraction problem. 6 minus 4 is 2. 3 minus 0 is 3. 7 minus 1 is 6. We get 632 and 15 298ths. Can we reduce 15 298ths? Well, let's see. Does 2 divide 15? No, it doesn't. 3 divides 15, but does 3 divide 298? 2 plus 9 is 11, plus 8 is 19, 1 plus 9 is 10, 1 plus 0 is 1, so indeed, since we didn't get 3, 6, or 9, 298 is not divisible by 3. 15 is divisible by 5, but 298 is not because it doesn't end in 5 or 0. In fact, the only number that divides both 15 and 298 is 1. So our final answer in simplest form is 632 and 15 298ths. A problem that initially looked a bit difficult, but really isn't. And I think that's true with many fraction problems, and hopefully what we've seen in this lesson is that if we stick to our understanding of fractions, that the denominator is the place value, and that the numerator is our digit, and in order to subtract, we must have the same place value. That is, we must have a common denominator. If we use our 5-step process, I think we'll see that subtracting fractions is not too difficult. So once again, just to be sure we've got it, the first thing we do is we get a common denominator. Lowest common denominator if possible, but you don't have to use it. The second thing we want to do is we want to get the numerators of the equivalent fractions, just like we did with adding fractions. In fact, the first 2 steps in subtracting fractions are just like the first 2 steps in adding fractions. The third step is borrow if necessary. Don't borrow just to borrow, only borrow when you have to. The fourth step is to subtract. Subtract the numerators, keep the denominator, subtract the whole numbers. And the fifth and final step in the subtraction process is to reduce if possible. You remember those 5 steps and use them every time you subtract fractions, you will have no problem. In our next lesson, we'll go to the next thing, of course, which will be multiplying fractions. And I think you'll find that it will be equally as easy as adding and subtracting. See you in Lesson 7.